So assembling this machine is going to be relatively straightforward after you're done painting. You're going to put all the screws. They're all going to be 2mm screws inside here. First, so there's 2mm screws here, two 2mm screws here. They're about, I'd say, 12mm long. And then you put a small nut on the end. The pins here are 4mm pins, 4mm pins. Again, you need to cut these to the length here, which is about, I'd say, 27 millimeters for this one. This one I used pins that were, I think, 12 or 16 millimeters long. This one's a 3mm pin. Again, it's about 10 millimeters, 12 millimeters. These ones are all 10 or 8 millimeters long. These are all 3mm pins as well. When I mean pins, they're like dowel pins, but metal dowel pins. Up here where the bucket is, you're going to have a 3mm dowel pin that goes across. These will probably be like a 12 or 16 millimeter. What else we need to do? Attach these guys, the handles for the guy to, your action figure to get in and out. The little step here. Decals, put them where you feel you want to. Again, if you want to be authentic, you'll put them in the same spots that I have them. These are all done by Cricut. Most of them are. These are all printed on a printer, the actual decals. These are all super glued on. Where are we here? Internally, we're going to put screws to attach the motors, which are 3mm screws by 8. This cog, or the sprocket, there's going to be a set screw. It's a 2mm. You'll buy one of these kits and it comes with all the right stuff. This is a 3mm by 6mm, sorry, an M3 by 6mm. These are set screws. I'll put a link to all the screw kits that I purchased and the pins. But the dowel pins, these longer ones, I actually buy a rod that's longer and I cut them down to size. For here, you're going to have an M2 rods that are about 16 millimeters. They come from this kit. Okay, so there's 16 mil, 2 mil, right? You're typically going to use these ones here. None of the 4mm. Actually, the 4mm by 16 is these ones in here on the top. All right, if you need screws, I got these ones. Again, these are all from Amazon. And they have a 2mm, 3mm, 4mm, or M2, M3, M4, M5. The nuts and the washers as well, right? So when we need a certain size, we'll use those. They have 20 of each and 45 of the M2s. As far as the magnets back here, I got these little magnets. They're neodymium magnets. They're from Amazon as well. And then any of the wires that I soldered I purchased on Amazon as well. The ESCs are from Robot Shop. The motors are from Amazon. The sound kit is a tiny, this is a Das Micro Mini sound kit. You can get the micro, which is a little bit smaller, and that's from AliExpress. And the receiver, depending on which radio you're going to use, is FlySky for this particular application. And then there's a BEC as well. So you're going to need a BEC, battery eliminator current. This is also from Amazon. At least I got it from Amazon Canada. It's a UBC or UBEC. So soldering all this, basically you're going to get all the red and black wires to a little board here. So I have a positive and negative side here on this little chipboard, and that's where all my powers go. So all the reds go to one side, negatives go to the other. That's for the ESCs. Next we have from the receiver, you're going to have a male to male servo wire that's going to go into your prop 1, and here it's going to go into channel 6 because we're going to set up a channel 6 switch so that the sound can run. It's a skid steer sound. Your BEC is going to go after the channel 6 to the BCC port. The boom they're going to get tied into one ESC, and I showed that in a video where how to solder this, but again, these are the ESCs, and that's going to go into channel 2. Channel 1 is going to be for the bucket on the servo, and the servo again is a modified servo that does 360 degree, but we can control how that works. Channels 3 and 4 are for the motors on the tracks, and those we're going to do a mix of the tracks so that we know when we push forward on the left stick, both tracks go forward. If we want to turn left or right, they move in opposite direction, and same going in reverse. So yeah, when we assemble all that, then we have to do, cable management. So we'll stick this all in here, put it all nice. We'll use a little bit of hot glue to stick this to the door and put everything else in its rightful space. We're missing a part here. Where's my... There's a battery tray that goes in here, and we'll glue that on after, but I don't know where I put it, somewhere here. But anyways, the battery tray will go right above these motors, so some of the electronics can hang out below. The other thing too to keep in mind is running the servo along the inside here. We have this little notch in the motor cover, okay, so that the servo wire will get through there, and then it'll feed itself inside. So that's that, kids. Once you got all that done, you should have a fully functioning skid steer. So in my build video, I didn't get into too much detail on certain areas, so I wanted to just touch on some of the final assemblies. When you are connecting the servo battery here, okay, you will have 2 screws to put in here. They're M3s. Okay, you're gonna put those in, attach the servo. The servo horn will be attached at the same time. There's no need for any attachments. Mine broke, so I just put a zip tie, but I'll be printing another one. So then you'll finally put in the 3mm pins to do the final assembly. So if you need to take it apart, take out these 3mm pins on each side. Okay, and then take these 2 screws out, and then you can pull the servo out. Now it may be a little bit tough because it's on an angle, right? That's because this is in the way. So you can take these 2 screws out on each side to pull this whole assembly out. Okay, this whole assembly can come out. Yes, it'll ruin your stickers. Your step gets glued on here in the middle, so figure out the middle. This one goes up here right at the bend. Okay, let's back up a little bit. The camera doesn't like zooming in. So that goes there. Same thing with this one. The top piece just goes right around there. Then you'll super glue this along the side here. Okay, super glue, and then it'll come into this little gap. Another thing I didn't show is how do you assemble these guys, right? Well, inside you'll put the bottom of this linear servo in, okay, with the little notch facing forward. Okay, doesn't really matter too much, but the little notch on the linear servo can face forward. The cable will go down out the back here and then through the hole inside. So what do I mean by that? Well, if we move this and open it, removing our engine cover, okay, this is where the servo wire comes in, or sorry, the motor wire for the linear servos, one on each side. Okay, you'll have to cut out a little notch here on this battery tray. Now it doesn't matter which side you put the battery tray. You can put it on this side or you can put it on this side, but it rests against the motors. All your electronics will be fed in between the 2 motors. Okay, these motors are attached, only 3 spots with those M3 screws. This top wing is attached with a long M3 screw. Okay, and then you'll have to cut off the end just to keep it flush. The magnet gets inset with some super glue. Okay, this gets a little bit of hot glue. These pins are M2 pins, and they'll go down and then they'll stop. I would suggest putting something on the bottom here to stop the bottom one from falling out. As you can see, I put just a little bit of 3D printed stuff. Underneath here, you can see how the motor is attached. I mean, the linear actuator is attached. right? The wires go back up. A little bit of super glue to hold those guys in. These are the M3 pins that I cut to fit in. And these are the M4 pins. I didn't put the actual guy like this on, but you can, and it'll be glued in place. The arm here, the same pin will go on this piece here. Okay, so when this lifts, you'll have that. So this is gonna, at full bottom, will be just touching. So I made sure that this was cut correctly, this angle. Inside, you can see I have a different BEC here, but that's fine. A BEC is a BEC. You can put your mesh here, some glue. The gas caps are painted, and then they're glued in place. Some more mesh. Most of the electronic ESCs are in the front here. Okay, this is all tucked in because when you go to put your seat, it's got to fit, and it's two pieces. And I sanded them lightly and then glued them together. This goes right in and it should be snug. Okay, so that it sits flush, and this should be pushed down. This should be off to one side so that your 1300 milliamp battery fits in this tray. Okay, this should be tucked in like that so the door closes. Now let's talk about the top. To assemble this, I showed in the video how to assemble it. So the sides get glued on to the top. These little railing or handles just get glued on. I didn't paint them. I put a little bit of white paint in here and then some Mod Podge to give it like that lens look. This is also glued on. Okay, there's your decals. I didn't put any decals on the inside, but you can put decals on the inside. And then the plexiglass in the back I just cut to fit in here. And again, I used some Mod Podge to hold it because it doesn't create any fogging like super glue does. And then this just slides on top and should sit snug. So it should be flush there on the back, sitting like that. So there you go. The motors, the undercarriage is connected by these two screws here, 1, 2, and then another one up front. It's going to be difficult to put them in on one side because you can slide your Allen key through one way and tighten them down, but then the opposite side you're going to have to do a little bit of work. Those guys are screwed in, and those guys are screwed in. You may have to shave this a little bit to make sure there's a little bit of clearance. Okay, so just shave the front face. And then there's a set screw on the inside here that you'll want to put first. Make sure you're aligned, okay, so that this is kind of, in the middle before you put your track on. The track goes on last. And there you go. If you have any questions, send them through. Okay, let's do some more work here. 3mm pin. This is one of the M3 by 12. We're going to push this sucker all the way through. Okay. Actually, we may even get away with an M10. M3 by 10. Yeah, M3 by 10. Let's do that. Let's start doing the electrical system. Now, first off, I'm going to put a little bit of flux on this side of this little board. Now, this board used to be a much bigger piece. It had panels all the way around. It's technically for a drone, but what I've done is I just need this for the power. So it'll be all the red wires on this side and all the red wires on that side. The nice thing is it also has a back too, so you can solder on both sides and they'll transfer. So essentially what we're going to do is we'll put all the connections on this side, and then we'll put one black and red wire here to go to the battery. So for now, we're going to get this some solder on here so that we can solder our connections to it. I'm not the best solderer or welder or whatever you want to call it in the world. I just do whatever I think works. So far it's worked out. Again, if you're really good at soldering, then good for you. But we're just going to put a little bit of the solder on here and get it nice and covered. And the flux is there to make sure that it cleans the metal so there's no issues or residue. So there you go. Both sides are now soldered up or tinned up, whatever you want to call it. And we're going to go work on the other electrical components. Now with this particular model, we're going to need 3 ESCs, electronic speed controllers, if you don't know what the terminology stands for. And the ones that I use are called tiny ESCs. They're made by FingerTech Robotics. These are about 30 some odd dollars Canadian, so in the US probably like 20 some odd something. In any case, it has a servo wire, it has a blue and a purple which goes to the motor, and then the other 2 go to a power source, which would be that little board. And we've got 3 of them. There's 2 here, one for the right motor, one for the left motor, and this one is going to be for the linear servos that go in the back. The servo in the front here does not need one because it is a servo. The other thing that we're going to need to solder as well, or solder, is a BEC. This will go to your receiver. Okay, so you'll get a receiver and you'll put it in one of the last channels. In this case, this FlySky one has a channel here for a battery, or connect a BEC there. This will then be connected to the battery source, right? Which is that little chipboard. And this regulates the power to here, so that when you're running your ESCs, we won't overload the servo as well. But when you're running these ESCs, you won't need to use the red wire. So we'll disconnect the red wire on the servos. We'll pull that out so that it's just the black or brown wire and the yellow or white wire, depending on what you're using. But in this case, it's going to be brown and yellow because that's the type of ESCs we're using. So the red one will be taken out and we'll supply the power through here. This will regulate the power. And that's what we're going to start on. Make sure you're going to use some sort of heat shrink to connect after you're done soldering. So make sure those are on first. Make sure they're big enough so that they can slide over when you're done all your soldering. In this case, with the black and red wires, we're not going to do any of this. The only time we'll need it is when we're connecting these ones here, right? We're going to have these wires all connected together. Okay, and I'll show you how to do all that. All right, so grab your soldering iron. Remember which one's which. This one's the positive, this one's the negative. If you need reassurance, just check it one more time. Okay, so we're gonna just quickly tap this here and make sure it makes a good bond. Let it cure or dry or stop melting. There we go. That is now attached. And then we'll do the same with all the other ones. All right, so as you can see, maybe I'm zoomed in a little too much there. I finally got it done. Just didn't like to be done on camera, but managed to solder these 2 black wires to the purple. So that's now done. And then we'll put the shrink tube on top. Cover those connections because we don't want to have any kind of issues, and then we'll put a little bit of heat and we're good to go. One final thing about the electronics I did not mention, these wires, so the black and the red from both of the linear actuators need to go to one of the ESCs, okay? The other ESC goes here, and the other ESC goes there. You can see that the motors are already pre-connected with the blue and the purple, okay? Each side has blue and purple. The blue and purple from the other ESC will connect to this red and black and this red and black, okay? So those two get soldered into the blue and the purple of one of the ESCs. So there's only 3 ESCs. These 2 motors get connected to that one ESC. And don't forget, remove the red wire when you're going to connect here for those 3 ESCs, okay? The red wire, I'm talking about the red wire on the servo wire coming from the ESC. Just pull it off. And there you go. Now I've done a video about this before, but we'll do it again because we're modifying a servo. So this is the 20 kg servo. This typically goes in here. I took it all apart, so there's 4 screws. Just pull them out, pull the case off. Remember there's O-rings around both sides, so don't lose them. In any case, so this is just the case for it. That's not the important part. The important part is this guy right here. This is the potentiometer. Now I've got it hooked up to a 6-volt battery. Do not go higher than 6 volts or you can kiss this thing goodbye and you can damage that. And these aren't cheap. They're about 30 bucks here in Canada. So what you're going to do is you're going to hook up the negative and the positive to this servo tester, and then you plug your servo in to the other end. Now, the key here is this potentiometer, right? If we look at this, if I turn it, you hear the servo's moving, right? The motor's spinning. And if I go the other way, it'll do that. So we want to find the center point, which is right here. So it's not moving. This is very important. This is the point where you want to glue this piece. But the other thing we need to do is we need to cut the top of this off, because when you put this inside here, it's going to sense where the servo is, right? So if you look inside the servo, it shows that the horn is about there. So this is essentially where the servo would have been. You can see how it's starting to move now. So that's the center of the servo. I want to make sure it's like that, zeroed out, right? But before we do that, we need to make sure that this top piece is cut off so it does not interfere with this top portion. All right, so the other thing too is you can kind of tell, right? What we want to do is make sure this is in the neutral position. It cycles. Put it in this dead zone. Okay, so in neutral, there. When it's in neutral, that's the center. We want to make sure that this servo is not moving whatsoever. Okay, so let's go cut the top of this off and then still make sure that this is not moving. The servo is not moving. This is in neutral. Okay, so doesn't matter where I move this knob. As long as it's in neutral, it tells me this is the center point of the servo. Then what we're going to do is we're going to super glue this so it doesn't move after. Then we can control this like a regular linear actuator that holds its position, right? If we move the stick forward, it'll move. When we let go of the stick, it'll stop. Different than a regular servo. Okay, so here we go. Snip. Oh, it's a boy. Kidding. Okay, so there we go. Center point. I snipped off the end. Don't tell your doctor. So just a drop of glue, let it cure, make sure that it dries in this position. Well, now that it's together, then we'll put this back in the case, okay? And then it'll work just like a regular hydraulics cylinder. So just to show you how this works, now that we've made the modifications, we put this back. Oh, look at that, see? But I can stop it and then... Look. Now it's stopped. If I leave it in the middle, it stops wherever I leave it last, right? So when you go and move your stick, and then you can move it more or go back. Now, what's the danger of this? The danger is if you over rotate, right? So we have this one here, has the same setup. If you over rotate, this thing will keep rotating and eventually you'll get to a certain point where it'll break. And I've got the, scars here to show it. It'll break right off and you'll have to reprint. Now you can set limit switches if you'd like. I'm not going to do that here because I set this slow enough that if I do go, it'll only go a certain speed, which is more realistic. And when I pull the bucket back, it has not as much power to pull in, but I'll know once it stops, it kind of stops. It's more of a visual thing, so yeah. Okay, let's begin the assembly. Now, the front track carriers, what we're going to do is we're going to slide this guy in. Okay, we'll start at the back. It's easier just to do that because what we're going to do after is put the front bogie wheel in. And there you go. Now we'll put a lock nut here. So what I'm using are M2 lock nuts and M2 by 30 screws. So these are the screws. These are M2 by 30, so 30 millimeters to under the head here. And these are M2 lock nuts. So what we'll do is we'll put the lock nut on, and we don't want this super tight. We just want it snug, but enough so that this wheel does not bind or it doesn't pinch here, okay? So I'll put that on and tighten it with one of your, these guys. You can use one of these guys if you have them. Just put this against here. And then with your your Allen key, which would be the smaller one here. And just tighten it down. And then do that for both sides. There you go. One down, 9 more to go. Well, yeah, 9 more to go. And then we have the back ones, which are a little bit different. Those ones look like this. I painted the outside. Essentially, it's going to use the same thing, but here you have the option of adding in a couple of washers, M2 washers, and you would put this in as well. Point, you've put in most of your rollers except for the last 2. The reason why we're doing this is because it's time to get your 4mm rod. Now they sell these in 100mm lengths in packs. That's what I did. I bought them in a pack of, I think, 10, and they're 100mm long. At the 50mm mark, I made a little tick. We're gonna cut that with our with a tool, and now you can cut it with a grinder, which is what I'm gonna do, or a Dremel tool. But essentially, we're just gonna cut this in half so that we have a piece of threaded rod, or sorry, rod. And the reason for that is because we have our 4mm hole here, and this is going to slide inside there. Now, why do we want to do that? Well, because there's 2 options. You can get the springs, right, to have some tension, and put it on here. So essentially it's going to look like this with the rod through. Now the rod does go inside here. This will go like that. When you feed this through, make sure that this groove is facing down. Okay, and that'll go in like that. Now remember to put your idler wheel in here, right? And the idler wheel is going to go in here. You're going to put your bearings in here as well. And then you're going to put your 3mm. You don't have any, do we? Okay. Now you can buy it in a kit, but we want to get the ones that are 16mm long. This one's 12mm long, so I'm just going to get a piece of my 3mm rod, but that's going to go through the middle, and the bearings are going to be on both sides. The bearings that we're going to be using are these ones here. They're a 3x6 by 2.5mm. They come in packs of 10. Probably wondering, like, why am I buying all these things? Well, you wanted to make this. Well, this is how I make things. Okay, so the 3mm will go through on the one side like that, and then this one will go on the other side, and they need to be flush. Okay, now if it's tight and it doesn't want to go in, get your X-Acto knife and just shave a little bit till it pops right in, but it should be flush on both sides. Why? Because that's the tolerances I put on this. So once it's in, it should have really not much play. Okay, so this is your opportunity now to put that in. Now once this is in, you'll see this is, now this spring that we have here, it's from a 3D printer. Yeah, that's right, see? Now it has some flex to it. And if you don't want that flex, you can essentially take that out and put in the 3D printed solid piece so it doesn't actually absorb or contract. Now you're wondering about this hole here. Well, that hole lines up with the outside there of that track. So push this back out. There's that hole. Okay, so that's push in. Once the wheel is in, it'll allow you to pull it all the way in, and then you can slide this something in there to hold it from popping back out. Essentially, that's what I did, so that you don't have to try to throw the track on. But again, you don't really need to, but I did it anyways. So let's go cut this guy. You need this, and then you'll glue it in here. And here you want it to slide freely, so you can remove your front idler if you need